Mathematics isn't only about number, it's also about shape, and many other things as well, but in this video we're going to be considering the shape known as a cube. This is a shape that's three-dimensional. It has not only length and width, but it also has depth. One of the issues that we run into in working with three-dimensional shapes is that it's most convenient for us to work on paper. And what that does is it takes our three-dimensional shape and it basically squashes it flat. We lose information. Here I can see the front of the cube I'm representing and the top as well as the right-hand side, but I can't see the bottom, the back, or the left-hand side. So if I'm asked a question such as, well, what if we cut this cube up? What if we slice through it this way and create 3 equal slices? But now let's do that in every direction that we can. So I've sliced through it vertically, let's say, and then I want to slice through it horizontally. And then I notice I haven't sliced through the top in another way that we could do vertically as well. So let's go ahead and do that. So I've sliced through every single face of this cube. So basically, this cube is now made up of smaller cubes. We've got 3 cubes going this way, 3 cubes going this way, and 3 cubes going this way. What is the volume of this? In other words, how many smaller cubes are now making up the larger cube? And I have found that that can be a challenging question for many people to answer. One of the things that happens is that people tend to get squares mixed up with cubes. So people might want to do something like count this right here as 1 and count this as 1 and then count this as a separate one. But this corner up here is actually just 1 cube. We see 2 squares, but it's 1 cube. So something that we can do to help our visualization here is to consider, this looks a bit like a Rubik's Cube. It's a little sloppy, but here's a real Rubik's Cube. So in order to develop some intuition about this, think about how many little cubes it would take to make up this object, and forget that there's a fancy mechanism in the middle that allows you to turn it. Just pretend that these are solid cubes that have all been glued together. So how many cubes would that be? And another way that we could think about that is to use blocks. And so the question becomes, how many blocks of this size do I need to make in order to build a larger cube that has 3 across the bottom, 3 up and down, and 3 back and forth? Well, let's see. Here's 1, 2, 3. And I need a solid bottom there. So I need to have 3 in terms of its depth. But this is not 3 cubes tall. So I need to keep building. I'm going to build another layer. So actually right now I have 9 cubes. This is just a single layer. You can count the cubes: 1, 2, 3, 4, 5, 6, 7, 8, 9. But now I'm going to build another layer on top of that one because we need it to be 3 layers tall as well. So let's keep going. Okay, but now this is only 2 layers tall, not 3 layers tall. And so I'm going to need to put 1 more layer on this. So far we have a layer of 9 and another layer of 9 for a total of 18. 9 plus 9 is 18. So why don't we just count this one out? We were at 9 plus 9, which is 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So it takes a total of 27 cubes. Now it's nice to work with this because I can actually take the pieces apart and I can physically count them and see how many there are. But this has its downsides as well. You know, if I try to move it around too much, it's probably going to fall apart and that's not going to work so well. But I can use different representations of a cube. Oh, there it goes. In order to get an idea of how to answer this sort of a question.